Okay, so we are going to study the sixth lecture of module 1 today, and that is liquid crystals. As the word suggests, what are liquid crystals? They are an amalgamation of liquid and crystalline state. That means they must be falling somewhere in between the liquid state and the crystalline state. They are neither pure liquids nor pure crystalline solids. So, what all are we going to study in this particular lecture? Introduction to liquid crystals, properties of liquid crystals, classification of liquid crystals, and applications of liquid crystals. So, we are first into what are liquid crystals, and if we remember from down the ages, as a child also we have been studying a lot about matter. So, matter can broadly be divided into main three states that we have talked of a number of times, and that is matter can be solid, matter can be liquid, and matter can be in gaseous state. But you know, there exists a state of matter which is somewhere in between the solid and the liquid. That means it is neither completely solid nor completely liquid, and this state of matter is known as the liquid crystal state of matter. Actually, technically it is called the mesomorphic state of matter. So, how do we define liquid crystals? So, liquid crystals are a state of matter which has properties between those of conventional liquids and those of crystalline solids. For example, a liquid crystal may flow like a liquid, like a normal fluid, but its molecules may be oriented in a crystal like manner. That means, like the way the molecules are arranged, the unit cells are arranged in a crystal, we may find an arrangement of the same kind. So, the liquid crystalline state is often called the mesomorphic state of matter. It is a Greek word which means intermediate, and the substance itself is called the mesophase. That phase itself is called the mesophase. So, therefore, there are certain solids, especially the example quoted over here, para-cholesterol benzoate, which was one of the very first molecule to be identified associated with the liquid crystalline state. So, there are certain solids, when we start heating it up, it first changes into a turbid liquid, and then definitely at a specific temperature, and then changes into a clear liquid at another sharp temperature. So, the question arose that what is this in between state which is neither a pure liquid nor a pure solid, still shows some of the properties of a liquid and some of the properties of a solid. So, this mesomorphic state or the in between state or the intermediate state of matter, which shows partial characteristics of a crystalline solid and partial characteristics of a pure liquid, is termed as the liquid crystal state of matter. Now, for instance, for para-cholesterol benzoate, if we have a look at it, then you know at normal temperature it is solid. So, this particular molecule at normal temperature it is solid, and if we start heating it up at about 145 degrees Celsius, it changes into a turbid liquid which we call a liquid crystal, and this temperature is known as the transition point of this particular solid. Now, when this turbid liquid further heated, it changes into a clear liquid, and that happens at a temperature 178 degrees Celsius. At 178 degrees Celsius, it becomes a clear liquid. So, this particular temperature is referred to as melting point, and the temperature at which it changes into a liquid crystal is termed as its transition temperature. So, certain solids undergo two sharp phase transitions on being heated. What happens? They fuse they fuse sharply, giving a turbid liquid, which on being further heated gives a clear liquid equally sharply. So, for in between we get the liquid crystalline state, and then finally we get the clear liquid state. So, these turbid liquids have different physical properties in different directions. Why? Because they contain a partial crystalline structure still in it. And since two liquids are isotropic, that is, they have same properties in all the directions, while the anisotropy is a property which is related to crystalline solids like mobility, surface tension, viscosity, etc. So, therefore, these particular as we said, so therefore, the intermediate state of matter, which is mesomorphic state of matter, which has partial crystalline solid properties and partial liquid like properties, they are termed as liquid crystal state of matter. Now, let us have a look at the properties of liquid crystals. What are the properties of liquid crystals? So, these molecules may be rod shaped or disc shaped. The molecules of course are anisotropic in nature, assuming that the direction is if you look at the direction of orientation of various unit cells. So, if I present them by an arrow, then this arrow is termed as the director of the unit cells. Each molecule is oriented at the same angle to the director, and these molecules possess very strong dipole moment. The liquid crystal molecules prefer to align parallel to each other because of the strong intermolecular attraction, और जिसको हम कहते हैं pi-pi interaction. So, these are some of the properties of the liquid crystals. Now, let us classify the liquid crystals. Broadly speaking, liquid crystals can be generated by two modes. Mode number one, what we do is we take a solid, we heat it up, and when we heat it up, it gives a turbid liquid, and finally it changes into a pure liquid. So, this turbid liquid, as we said, is a liquid crystalline state. So, once a liquid crystal, when a liquid crystal is prepared by the process of thermography, that is heat, by process of heat or heating, that is known as thermotropic liquid crystal. Now, there is another way of preparing the liquid crystals, and what is that way? That way is that you take a solvent or solution of the solute into, of course, a solvent, it is in liquid state already, heat it up a little, concentrate it a little, and then you get an intermediate state which is neither a pure solid state nor a pure liquid state, that again is a liquid crystal state. So, that too is a method by which liquid crystals can be generated. So, the thermotropic liquid crystals are generated by the process of heat exchange by heating it, and lyotropic liquid crystals are prepared or produced by exchange of solvent. So, by exchange of solvent means lyotropic. Lyotropic can either be lyophilic or lyophobic. What do we mean by lyophilic? That means solvent loving. If you dilute it and prepare a liquid crystal, that will be termed as lyophilic. Now, if you remove the solvent and prepare the liquid crystal, that will be known as lyophobic. Phobia means fear, dar. Okay? So, this is how the liquid crystals can be prepared in two broad ways. So, accordingly we are classifying the liquid crystals also. So, that means the thermotropic liquid crystals are one of the type under which we can study pneumatic liquid crystals, smectic liquid crystals and cholesteric liquid crystals. Whereas, the lyotropic liquid crystals can first be classified into two classes, that is lyophilic and lyophobic, solvent loving and solvent fearing, hating. Now, they can further be termed or classified into lamellar, as the name suggests. Lamellar means sheet like a lamina. Cubic, pneumatic, depending on the shape, of course, they are termed as Pneumatic we already took it up earlier and we will be studying it in detail also. The word pneumatic in Greek actually means thread like. They have their structures in a linear manner like a thread. And then hexagonal liquid crystals are also there. Of course, we are not taking all for our consideration. We have just picked and choose the important ones we are going to consider for the study. Now, the first liquid crystal we are going to take in detail, and that is pneumatic liquid crystal. Now, what is pneumatic liquid crystal? It is a liquid crystal which has a shape quite in consistence with a thread like, longitudinal. Okay. So, pneumatic liquid crystals. What are pneumatic liquid crystals? The word pneumatic actually is a Greek word, of course, derived from pneuma, which means thread. So, they appear thread like. They show some of the following properties, and when we consider this particular topic, the type of questions that are asked on this particular topic, you may be asked a general question like what are liquid crystals, and you have to give a little definition of it and detailing of it, or at times differences between pneumatic and smectic may also appear in your examination paper. So, what are pneumatic liquid crystals? In fact, these liquid crystals do not have positional order of the unit cells, but possess orientational order in it of the unit cells. The molecules have elongated rod like shape and are thread like in nature. Do not have layered structures. That means the layer like arrangement of a crystalline solid disappears in this particular state. They flow like normal liquids and they have low viscosity. Okay? Because they have more fluidity, therefore viscosity is going to be low. So, while writing the differences between pneumatic and smectic, you can take care of these points. You can take these points into consideration. Formed at relatively higher temperatures, can be aligned by the application of electric or magnetic fields, and some of the popular example for pneumatic liquid crystals are para-azoxyanisole. This is one of the first synthetic liquid crystal that could be produced in a laboratory. So, the pneumatic liquid crystals, in fact, they have what kind of a structure? A thread like structure. So, if I have to draw a cross sectional view of a pneumatic liquid crystal, the unit cell, the long axis of the unit cell may appear like this in the cross sectional view. Okay? So, this is pneumatic liquid crystal. Let us take up the next, that is smectic liquid crystals. So, what are smectic liquid crystal? The word smectic in Greek means soap like. So, they are soap like and are clayey or greasy in nature. Like clay is very slippery to feel, grease is very slippery to feel, and if you feel soap in your hand, that too is very slimy and slippery to feel. These liquid crystals have same kind of a feeling in it. Okay, so the molecules are cigar shaped. Earlier, if you remember earlier, in pneumatic, the molecules were more like a rod shaped structure. They are cigar shaped. Okay, and these are arranged in layers and have layered structures. Now, you can see the diagram over here. You can find the layers one below the other. You can find the layers one below the other, and because of their layer structure, they are slimy or soapy to feel. And if I draw a very simple structure of it, it could be drawn something like this. For the smectic liquid crystals, they are arranged in layers also, and because of this reason, they slip over each other and they retain more of crystalline behavior as well because of this particular arrangement of it. So, what we said that they do not flow like normal liquids and have limited mobility. Limited mobility, why do they have limited mobility? Because of the retaining of crystalline structure as yet, अभी भी क्रिस्टल स्ट्रक्चर इसमें काफ़ी मेंटेन रहता है, इसलिए इनका फ्लो रेट थोड़ा सा कम होता है. Are of two types, smectic A and smectic C. You can see both. Smectic A, you will see the straight arrangement. Smectic C has a slightly tilted arrangement, not affected by external electric or magnetic field because they still maintain their crystalline nature, flow in layers, and different layers can slide over one another, and that is why they are slippery or slimy in nature. Have short range orientational as well as positional orders, and they have high viscosity, like they are flowing but still not like pneumatic liquid crystal which have quite a free flow in them. So, they, because they retain more of the crystalline nature, so when we heat a solid, first it changes into smectic and then it moves on into a pneumatic style, pneumatic behavior, pneumatic nature. One of the example is para-ethyl one of the example is ethyl para-azoxyphenitol. This is one of the example of smectic liquid crystal. So, now let us take up cholesteric liquid crystal. What are cholesteric liquid crystals? These, the name has been derived from cholesterol, but cholesterol itself may not be a liquid crystal. Derivatives of cholesterol show liquid crystal like behavior, and they are helical in nature, like if you remember the DNA and RNA structures. So, they are helical in nature, they are like helix, okay. And when we talk of cholesteric liquid crystals, they are an amalgamation of smectic and pneumatic both. They are an amalgamation of smectic and pneumatic both, okay. Pneumatic mesogenic molecules containing a chiral center which produces intermolecular forces that favor alignment between the molecules at a slight angle to one another. So, you can see they are moving in a spiral way from one to another like this, okay. So, if we have to draw, they have those helical structures like helix. This phase is usually observed from the cholesterol derivatives, and the molecules are essentially chiral and are arranged in smectic liquid crystal like manner, like in layers one below the other, but those layers like a twisted rope. If you have seen a rope, now you twist a rope nicely, that will be the shape of a liquid crystal which is cholesteric liquid crystal, okay. The structure is similar to pneumatic phase, also known as chiral pneumatic, and therefore, they are known as chiral pneumatic. Each layer in cholesteric liquid crystal is tilted with respect to the other, and hence the molecules take a one complete turn of 360 degrees to make a helix. Now, pitch is inversely proportional to the temperature. It is affected by temperature, pressure and electric, and that is one of the reason why cholesteric liquid crystals tend to change color with change in temperature or change in pressure, etc. So, they are very popularly used for a number of applications we will be taking up in a while. With respect to them, like the color, because of the color change, they are used with temperature, they are used for a number of medical applications also, wherein this particular property comes into existence. So, if you have seen some kind of MRIs, etc., wherein you see the picture of a brain in multicolored patches in it, and that is because we use liquid crystals and especially the cholesteric liquid crystals for that particular study. They are also used for the study of skin cancers, and because the carcinogenic area in a body has higher temperature, and at higher temperature these liquid crystals change color. So, for this particular reason, one of the example is cholesterol benzoate for this particular liquid crystal, and it is, of course, we know that one of the very first liquid crystal that was identified and studied in detail. So, apart from that, we will take up lyotropic liquid crystals also in general, not in detail though. So, lyotropic liquid crystals, what are they? As I said earlier, they are prepared by exchange of solvent, by either removal of solvent or by entry of solvent or by adding solvent to it. So, they are prepared by exchange of solvent, therefore, in short we may term it as LLC over here for our study. Okay. So, what are lyotropic liquid crystals? These are obtained by change in the concentration of solvent. Of course, temperature change, like you have to remove the solvent, then definitely you will have to change the temperature a little to remove the solvent. So, these are, what happens is, these are solvent dependent or concentration dependent entities. So, the LLCs, that is lyotropic liquid crystals, are made by adding, what do we do, solvent to the solid until a critical micelle concentration is reached. Okay. For further addition of the solvent liquid crystal, if you keep on adding solvent to the liquid crystal, it will change into a clear liquid, it will not remain a liquid crystal any more. Okay. So, this is how these liquid crystals, the lyotropic liquid crystals, may be prepared by exchange of solvent. Okay. Now, these are made up of two types, two parts. The liquid crystal has two parts. Now, you can see over here, also it has two parts. One is the head part, this is the head part, and the other is the tail part. Okay. So, the other is the tail part. So, we have hydrophilic polar head and hydrophobic tail. So, they are amphiphilic in nature, and some of the examples like the molecules of soap, the phospholipids present in the cell membrane, etc., they are lyotropic liquid crystals. Okay. So, now let us talk of the applications of liquid crystals, very important. Why? Because liquid crystals are widely used in a number of ways in our day to day activities. Now, what are the major applications? There are broadly two major applications of liquid crystals. What are those two broad categories of applications of liquid crystals? One is with respect to the LCDs. I hope you are very familiar with the word LCD, you are using it so very often in your everyday life, and that is, the word LCD means liquid crystal display devices, LCD, liquid crystal display devices. Now, what are liquid crystal display devices? The liquid crystal display devices, like in your laptop screens, like in your mobile phones, there are so many places where you see the traffic signals, etc. They all have LCD screens which work on the concept of 0 and 1, and you may have also studied it sometimes in your other physics or some other studies. So, what are the advantages of LCDs? Basically, we will talk of, and then we will discuss the liquid crystals, which are the applications. So, for liquid crystals, for the LCDs, they have low power consumption per unit area, viewable over wide range of light conditions, relatively easy to design for more than two colors. So, earlier we had only black and white televisions, now we have colored televisions, and then now we have a wide range of colors that are easily depictable on our television screens. So, and of course, the clarity of colors is also very, very fine with respect to the visibility. Okay. So, and they have low operating temperatures and low operating voltages as well. Even at low temperature, they can be easily used, the LCD screens. Now, applications of LCDs. Okay. Of course, digital and alphanumeric display with the help of LCDs, calculators, mobile screens, etc. Then signal displays like traffic signals you have on your vehicle, on your car, on your motorcycle, the signals are displayed on a particular screen, that again is an LCD screen. Okay. Then petrol pumps, you have signals, in industries you have signals, they all have LCD screens on which the signals are displayed. Then you have advertising displays, they all are like these days when you move on the road, you will find so many LCD screens wherein the advertisements are being displayed. ये भी LCDs आपके liquid crystal display devices ही होते हैं. Then large area picture screen, just suppose a cricket match is being played somewhere, and then at places, a number of chaurahas, a number of places, you have huge screens displaying the cricket matches, the various advertisements. And very important is image converters, like X-rays you get. So the images are converted into the real picture using LCDs. Night vision equipments, either in ships or in aeroplanes, they also have LCD screens. Okay. Analogous display like the television channels, the pH meters, okay, the digital thermometers, they also have small LCD screens. The BP instruments, the diabetic measurement instruments, digital diabetometers, etc., they all have LCD screens in it. And of course, of late, during a lot of pandemic, corona pandemic that is going on, each one of us have pulse oximeter at home, which we clip into our finger. That too has a small LCD screen which gives you your pulse and the oxygen level in your blood. That too has the LCD screen. Now, the other application of the liquid crystal is known as the thermographic application. What do we mean by thermographic application? Thermographic application has to do with temperature. The word thermo always means temperature, it has to do with temperature, and majorly it is the cholesteric liquid crystals in combination at times with pneumatic liquid crystals which are used for the thermographical studies. So, what are thermographical studies and where all do we use thermographic liquid crystals? The thermal mapping in solids, of course, like electronic devices, ICs to locate faults, we use thermographic liquid crystals. Then surface thermography in aerodynamic studies, like you have an aerodynamic model, the top of it is covered with a liquid crystal material, and then if the design is not good, it will show change in color, and accordingly you will change your design. And I give this particular example at IIT Kanpur. They have a wind tunnel in which the thermographical studies, the fluid dynamic studies are conducted, and that there also you can use a lot of liquid crystals for that particular study. And then we have testing of radiators, and then we have of course finding efficiency of heat exchangers, etc. So we use such things. Then there are n number of pharmaceutical, there are n number of applications in pharmacy for the liquid crystals, like the thermography of human skin. Wherever you have carcinogenic cells, the temperatures change. Wherever you have a tumorous cell, the temperatures change, they rise. So it shows color change, and you can detect if you have that kind of a problem. Okay. Then basic study of the circulatory system of your body can also be used liquid crystal and take up that study. Diagnosis and detection of tumors and cancers are also done with the help of liquid crystals. So, this was regarding the liquid crystals. We took it up today, and of course, there are some questions which are importantly asked on this particular topic, like what are liquid crystals? Write a note. What are liquid crystals? Differentiate between pneumatic and smectic liquid crystals, and also write a few applications. So, these questions you should take it up for your studies. So, this was your teacher teaching you liquid crystals today. So, I hope you had a good learning, and of course, all the best for your exams. Thank you.